We're going to turn a chemistry equation into a math equation, and it's going to be kind of spooky or kind of magical, depending on how you see it. So let's take our acid dissociation equation. We have our acid, it dissociates into the hydrogen ion and the conjugate base. And we know that we can put this inside of an acid dissociation equation. K subscript A is equal to, we're going to have our fraction bar. In the numerator, we're going to have the product, so that's going to be H plus, and the A minus ion. And in the denominator, we're going to have the undissociated acid. But I'm going to take something in this numerator. I'm going to take the concentration of the hydrogen or the hydronium ion, and I'm going to pull it out, and you'll see why in a moment. Now that we have this pulled out, I'm going to take the logarithm of both sides. It's helpful if you review the rules of logarithms from your math class, but here's how this is going to work. I'm taking the log of the Ka, and that's going to be equal to, we're going to have the log of the hydrogen ion concentration. And the rules of logs say that if you take the log of a product like A and B, you can just add them. So it's going to be plus the log. We're going to keep the A minus over the HA. We're going to keep that together. So it's going to be the log of, and we're going to have the A minus ion staying in the numerator position, and we're going to have the undissociated acid down here. So all I did was take the log of both sides using the rules of logarithms. Notice how here I have the log of the Ka and I have the log of the hydrogen ion concentration. I'm just going to swap their sides. I'm going to subtract the log of the Ka from both sides. I'm going to subtract the log of the hydrogen ion concentration from both sides, and they're going to be on opposite sides of the equal sign. And when that happened, they took on negative values because we did subtract them from both sides. But here's something to remember as we move forward. P means negative log of, so we're going to take advantage of that right now. We have the negative log of something and the negative log of something else. We're going to replace negative log with P. So here's what that looks like. We have the negative log of the hydrogen ion concentration, which we know is pH. That is equal to, and then we have the negative log of Ka, which is called the pKa. And then we just put the rest of it. And now you have the Henderson-Hasselbalch equation. So we have the concentration of the conjugate base and the concentration of the weak acid. It isn't a lot of steps, but it is pretty cool to see where it comes from.